Okay, and there you have a solve Leetcode 1143, a dynamic programming question. Question is given two strings, text 1 and text 2, return the length of the longest common subsequence. If there is no common subsequence, return 0. A subsequence is a string. A subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E. A common subsequence of two strings is a subsequence that is common in both strings. It's in option way I'm my other examples. Basically, I'm my two words, right? And I have a kind of string, right? I'm my two strings. And I'm say between who baku in baku ni mua, right? The order doesn't matter, or the order matters, but the position doesn't matter. For example, if I say we A, B, C, D, E, right? And mama another one to say A, C, E. And subsequence does not necessarily mean say order and be the same, right? Inti won't say way anyway the same order. Way and matchy BBR, right? But way matchy way and a E no matchy way. They are in the same order. A about first, C ni C by second, and a D ni D by way. Nanka E no wa say ya. If I say BI say A E C A no will be the first one, right? C ebeko A B C no beko akoka way, but yen to mean for E no M say because it will not follow the same order because line across it each other. Any nine was any nine the same order, so the order matters, right? But the position doesn't matter. We'll show the next example. Or say A, B, C, right? And the second one is A, B, C. We'll show we are order no match, pepe. Use order no match, and order no match, right? But position no doesn't really matter. You can see bit my bar say and a last example near A, B, C, and a D, E, F. So A, B, C, D, E, F. Osha, nothing matches anywhere. Like we are matching BBRC. We zoom match BBRC. We zoom match BBRC. And the question is stated say return 0. Into we say no. Longest subsequent will be 0. First one no. Osha, match the longest common subsequence is ACE and of length 3. 1, 2, 3, right? We so ABC we anyway match a pepe into that. But examples your mama has seen are very simple examples, right? Into yafa example we be to say. Yeah, example we to say who say first once no it doesn't match, right? It's in that case no then you be but who probably who say if you are anyway match it, right? And in such situations that's where we have dynamic programming. It's even say we anyway match. You have two options. We inquire to mark say, right? Now the way about compare way, right? And also it's an option. And we need to mark say, now do we compare way, right? And also it's another option. Because still no other no way to mark other no here. So anyway match here, these are your options. And you have to check all these scenarios to check say ubenya match. Ubenya match biya say we anyway match here be +1, right? So we anyway matches we need to reach my +1, right? And I say we anyway match here, both of them no also moving forward back. We be connecting back. Now we are connecting back because when we are matching, there is no need to perform analysis we on a complications we are saying we now be jump here connecting back, right? So you will write a function that checks say we anyway match here. So we anyway match here, check is say we and a way match here, and I say we and a way match here. Say match here now we increase it count by 1, right? Until you write a function that will call itself to check these ones and also now assign increase it count by 1, right? Until to understand and appreciate this solution more, you need to so kind more about dynamic programming. Let me show you here, right? Programming. There is another way of solving this problem. Maybe I made a video about how to use that problem, but it will be using more of metrics, because if you look at the two strings now, technically it is an m by n matrix, right? We are the length of x into we be length near m, I will length near n, n by n matrix. Maybe I made a video on that solution as well. But for now, here this first solution using dynamic programming to solve this, and then maybe I'll do a second video for this same solution using that matrix. The way we can solve this problem. So first of all, we create a function that is called find sequence. And we take in parameters like P1 and P2. P1 and P2 represent like positions inside the letter, right? If P1 is equal to the length of text, x1 or P2 equal to the length of text 2. Basically, what it means is when you move I see the end of the last index of text, right? Word no, word maybe index 0, 1, 2, 3, 4, 5, 6, 7, 8. Say P Baba we drew 8, which as such as you drew the end of this one, so there's no need again. Yapon, everything has ended, right? And you know, every return is 0. Another situation so I may describe here and say if text 1 is equal to text 2 index P2, it means say you back you are returning 1 plus CCI about first function right? Find sequence P1 plus 1, P2 plus 1. Again, I have said you never say P1 and P2 are the same, are equal to each other. So you have some free function in but with this time plus 1 because you move to this position, right? Now say yes, a situation where else the next thing we are going to do, we are going to return the maximum, right, or find sequence P1, P2 plus 1, and then find some free function view, recursively calling the function itself. P1 plus 1 and a P2. Right. So basically, the American has you're finding the maximum of these two, right? And when you say C way and I say A T, it's whatever will give us back over is 0, no back over into you're finding the maximum of that, right? No. We are and we call the function itself. So find sequence starting from 0 to 0, right? That is what we are going to return. And if you look at it now, first of all, you check is it drew the end of any of them. It won't be beyond you drew the end, then we end the case. But it's a text 1 P1 A equal to text 2 P2 we are yenya back. Both of them will be moving one step, right? Else, you will find it. You will move back forward. You back you will find the maximum of moving back forward. You back right? That is how we deal with a situation where honey match here. So you be moving forward, right? So honey match here, you be moving forward. This is how you be handle the situation, right? So let's see if this one. Okay, so this one didn't work. So we say text is not defined. Did you mean text? So the problem then is a text 1 variable near text 1. Okay, so this was the problem. So this is how you solve a problem like this. And we I think time complexity, like I said over here, will be m by n, where m is the length of the first one and n is the length of the second one, right? The space complexity is O of n. So, and I think and also by m by n because it's the same combination. But yeah, this is how you solve it. And also, as like I said, there is another approach of solving using matrix, and maybe I will do a video about that one too. All right, thank you. Bye bye.